So C here, C is what? C is a MAC function which takes two input. What are those two inputs? For the C, you will be passing message as well as the secret key which is shared between Alice and Bob. Okay, so see here, this is a C, a MAC function. In that function, we are taking two arguments. Consider that a message and a key. Okay, so this all we discussed. So this is the last topic that we discussed. So we when Alice wants to send a message to Bob, along with a message, Alice will append a Mac. So how Mac is generated at Alice side, a message will be given to Mac function, which is C of this function. Once it goes to this function, you will be generating what? Fixed size length called a Mac. So what Alice will do, this Mac and the message, this Mac, whatever the Mac it is there, and the message will be appended with the original message. Mac will be appended. So after appending, so this is your original message, this is your Mac. After appending, this sends to a Bob. So what Bob will do, what the Alice has done for calculating the Mac, the same Bob will also calculate the Mac by taking this message. If both are same, that the received message is not modified, it is correct. So see here, if both are same, this we already discussed. If both are same, then authenticate. Yes, it is from an authorized person, and it is there is no modification to that message. Okay, why? Because if with that key, if the it is applying a key indicates it is authentication, and if the command that is generated is same, that indicates that the message is not tampered while transferring. Okay, so this we already discussed. C K comma M is the Mac, and the input message Mac, and message authentication code. So this we discussed just now. So this is your message. This message, what we are doing, we are sending to C. For this C, I am passing two. One is message and one is K. So the output from this is Mac, the output from this is Mac, and the output from this is message. So both, what is the symbol? This is append. So it is appending along with a message, it is appending a Mac. So Mac is C K comma M. So it is appending, and what destination system is doing? Destination is doing the same what sender has done. What sender has done. So that if both are same, again the destination system taking the message and sending this to Mac function, and Mac is generated. Both this side Mac and this side both will be compared. If both are same, then the destination system will accept it. Okay, so in the same way, there are different ways. The problem in this is, listen all of you, the problem in this is, it will not provide confidentiality, it only provides authentication. Why? Because we are applying a key. Only an authorized users will know a key, only an authorized users will know a key. Okay, so that's the reason it provides authentication, but it will not provide confidentiality. Why? Because this message is a plain text. Okay, so when a sender is sending hi hello how are you, we are sending the same plain text in the transmission media, hi hello how are you, so that you can read it very easily. But why there is a need of sending it if the attacker is able to see this is, in this case we are considering authentication is very important, confidentiality is least. For example, if I'm sharing a schedule, exam schedule, okay, so that exam schedule, that this is on this particular date there is an IS exam, on the next day there is a CN exam, like that if it is mentioned, then what happens, ma'am? It should be, you should know that if I'm shared a message to you saying that on 24th there is an IS exam, on 25th there is a CN exam, then you should know that the message is from a authorized person or not. So from an exam branch, if there is a what a timetable is scheduled, you must know, is it right or not. What you will do, you will open the college site and you will see whether these are exactly the correct or not. So in that case, confidentiality not needed. So in some applications where authentication is very much important than confidentiality, in such case we can use this. But some cases where you need to provide your bank on in your online banking. In such case you cannot show that, yes, come and see this is my bank account password. I cannot broadcast my bank account password, that should be confidential. So in such case I cannot use this approach. So what I have to use, I have to use confidential. So that is this example that I have given for timetable. So exam, so in this more two are there in this message authentication code, try to understand. So in this what we are doing is, the problem in this case is message plain text we are transferring, right? So in this what we are doing, this is a message, okay, the same process until here is same, okay. So the message, the sender is sending to mac function, generating a mac, and here a plain message will be there. So for those both, it is using K2, which is symmetric. It is using K2 for encrypting this message and a mac, okay. After encrypting, it is transferring. So from this side, Analyst is sending an encrypted message with a key K2. But what happens before that is this process, okay. So this has to be decrypted at the receiver side with which key, ma? Can anyone? This has to be decrypted by the receiver with which key? With K1 or K2?
K1 ma'am.
Is it K1 or K2? See here, for generating a MAC, listen here, ma. For generating a MAC, we are using K1. Okay. So what receiver will do? Receiver will take the same message, will send to MAC by applying this K1. This is separate case. Okay. But the encryption is done with symmetric key K2. So it has to be done with symmetric key
K2.
K2. Yes, good. So this has to be decrypted with symmetric K2. After decrypting, what receiver will get? Receiver will get one side as a message, one side as a message, then the other is appended with a MAC. Try to concentrate. So here what the sender is doing, sender is sending one side the message, it is appending what message. So one will be message and the other will be MAC. From this you will be getting MAC. But we are not sending this exactly to receiver. What we are doing, we are encrypting this whole with K2 and we are sending. What receiver will do? This entire will be shared to receiver. Just a minute. So what receiver will do? Receiver will decrypt with this. After decrypting, what receiver will get? Message and the MAC. Okay, but this MAC which is calculated by sender, but now this MAC has to be calculated by receiver. So for that, the same process the sender has done for calculating a MAC, the same process has to be done at receiver side also. So what receiver will do? Receiver will take this message, will send to MAC, with K. Which key? Which key is used at sender side? K1 or K2? Which key is used at sender side, ma?
K1 ma'am.
So which key I have to apply here? Receiver has to apply K2 or K1?
For comparison, K1.
Yes, for comparison K1. So once if it is applied, we will be getting MAC. So this MAC is generated by the receiver. This is a MAC which is sent by the sender. Both has to be compared. If both are same, then the message is not been altered and it is providing a authentication and confidentiality. Okay. Now there is one more case where, see here, this is the second case. Okay. So what is the name of this diagram? Message authentication and confidentiality, where authentication is tied to plain text. In this case, message authentication and confidentiality, where authentication tied to ciphertext. Okay, means what? First, what we have done, ma, for the plain text. Let us consider the plain text as hi, hello, how are you. For that hi, hello, how are you plain text, we are sending to C function, which is MAC function, by applying a secret key K1 and we are generating a MAC. Okay, we are generating a MAC. But in this case, Hi, hello, how are you? What we are doing? First, we are converting this plain text to cipher text with the help of K2. Try to concentrate, ma. Here, the actual message, plain text, we are converting to ciphertext first. Okay. After converting this to ciphertext with the help of symmetric key K2, this ciphertext we are taking input for Mac, which is where it uses for converting ciphertext to Mac. We are using which function? C. So for this C, again we need to apply C means it will take the ciphertext as input, and the other one is K, which is K1 here. K1. So this encrypted ciphertext and the K1 both given so that we are generated a MAC. Okay. So this MAC, the MAC, here you will be getting MAC, and from this you will be getting ciphertext. Okay. So the sender will send what? The ciphertext and the MAC and the Mac. Okay, both are appended and will send. So see here, this is what? This is encrypt the ciphertext. How plain from how we are converted this plain text to ciphertext with K2, and this is with K1. So for this encrypted one, for this encrypted one again K1 is applied with it sends to function Mac so that a Mac will be generated. Now concentrate. Now I will ask you one question, ma'am. So here you will be having Mac, right? So what for comparison, sender has sent this, so receiver has received this Mac from this. Okay. Now next is what the receiver has to calculate. What the receiver has to calculate a Mac. So for that, already this is an encrypted format, so this is a ciphertext. Now tell me the answer, whether this ciphertext has to be converted to plain text or this ciphertext has to be taken as input for some Mac function. What you think about when a receiver is doing something? Think about the process that has done at receivers sender side. Sender has used what? Sender encrypted the message. After encrypting the message, the ciphertext is given as a message and K1. Now, the receiver has to do the same for getting this MAC. Already one part MAC is received. So now receiver has to generate a MAC. For that, what receiver has to do? Receiver has to take ciphertext or plain text as a message. So we have
Cybertext, ma'am.
yes, good.
Ciphertext,
So
ma'am.
we will be taking a ciphertext. So we'll be taking ciphertext. So for C, we'll be passing ciphertext, which will be available here. Next, which key? K1. So the same K1 will be applied. So receiver will also get a MAC. Okay, receiver will also get a MAC. So this MAC and the MAC which is sent by the sender, both will be compared. If both are same, then the received message is authenticated and confidentiality provided. Now, what exactly if it is correct, what a receiver has to do? Receiver has to read a plain text or a cipher text?
Plain text, ma'am.
Plain text. So this is an encrypted format. First, listen all of you. First, what receiver will do is receiver will try to calculate a MAC. If both are correct, then receiver will accept the message. Once if it accepting a message, but the message is in ciphertext, so a receiver, in order to read what message the sender has sent, the receiver has to decrypt that. So with which key the receiver has to decrypt? With which key? The symmetric means which key the sender has used for encryption, the same key the receiver has to do for decryption. So here for encryption, the sender has used K2. So for decryption, the receiver has to use K2. So this is a ciphertext. So this ciphertext will be received by the receiver, and receiver will decrypt this so that receiver will get a plain text. Okay. So there are three approaches for providing message authentication code. So first one is directly. It only provides authentication. Okay. So directly when Alice wants to send a message to Bob, Alice converts a message. One part will be the actual message, and the other part appended is the MAC of that plain text. The MAC of the plain text, and the same process will be done at the receiver side. Both will be compared. Okay, so the other part, this is the ciphertext. Can you tell me the title for this blog diagram? This is diagram, ma'am? Is it authentication tied to plain text or authentication tied to ciphertext? Is it authentication tied to plain text or ciphertext?
Plain text, ma'am.
See about this, ma'am. Here is an Alice. Okay. Here is a Bob. Okay. And Alice, whenever wants to send a message, what Alice is doing? First, it is going for encryption with K2. Okay. Then the encrypted means you will be getting from this side, you will be having plain text. Once you are encrypted means the output from this will be ciphertext. Think about input and output. So the input from this will be plain text. After encryption with the symmetric key K2, the output from this is ciphertext. So for Mac, are you giving a plain text as input, or are you giving a ciphertext as an input for Mac? Is it ciphertext or plain text? Anyone, ma? It is already given here, no? So it is given for this Mac plain text or ciphertext?
Ciphertext, ma'am.
Okay, so ciphertext means here, see, we are passing one as ciphertext and the other one is K1. Okay, so is authentication tied to ciphertext or plain text? I am asking. Is authentication tied to plain text or ciphertext?
Ciphertext.
Yes, ciphertext. Why? Because for this Mac, we are giving one message as the ciphertext and the other one is K2. This diagram is same, this one only. But I thought of asking you the question, so I kept separately. Okay. So understood. Authentication tied with, I will ask you the question. This is a message. This is a message. And this is given to C. And the key is K1, let us suppose. And here you will be concatenating this message. And this will be passing here. And now we are encrypting this with K2. Now tell me, authentication is tied with ciphertext or plain text? In this case, you see, ma, authentication is tied to plain text or ciphertext? Answer, ma, anyone fast? Think about, here is an Alice. I am not showing about Bob. Here is an Alice. Alice wants to send a message. So this message, what Alice is doing? Alice is sending directly this message to Mac function. Means what? Is it a plain text or ciphertext?
Plain text.
Yes. So authentication tied to plain text. So this is the example. So authentication tied to plain text. This is authentication tied to ciphertext. But we are providing confidentiality for sure. Why? Because we are encrypting that. So this completes your message authentication code. Okay. Is everyone clear? Should I repeat once again? Is it clear, ma? Mac?
Yes, ma'am.
Okay. So let me go to hash function. See here, ma. Hash function, we listen here. So we have, for providing message authentication, we have message encryption completed, message authentication code completed. Next one is hash function. Next one is hash function. So this is your hash function. This is your hash function. Converts a variable size message M into fixed size hash code. Okay. So can be used with encryption for authentication. So I will explain this each and every one with the help of a diagram so that you can understand even more clearly. See, first, this is an example for identifying a hash function. You will be having variable length, okay, that you are passing to hash function. See here, h of m, okay, means for hash function you are only sending a message. Think about the differences between a mac and a hash mark. So can anyone tell me, in a mac function what we passed? In a mac function we passed what? In a MAC function, we pass what? A message and a what we
Key,
pass?
ma'am.
Ah, yes, good. So for a MAC we pass message and a key. So that will not be happen in a hash function. So in a hash function we only pass message, not a key. So see here h of m. So means what? This message can be any variable size length. So it can be any variable size length. So finally it will be converted to fixed size message. Okay. Finally it will be converted to fixed size message. Okay. Almost MAC and hash look similar, but you should know the difference between a MAC and a hash. So in a MAC we are applying a key. So if you are applying a key, what kind of service we will be providing? If you are not applying a key, what kind of service we are providing? You must know. Okay. So if I am applying a key, that indicates that I am showing some proof for you saying that this is my key. Means authentication will be provided in a MAC. Integrity will be provided in a MAC, but that won't be happen in a hash. Why? Because with the help of a hash, you can provide integrity, but you cannot provide authentication. Why? Because anyway, you are not using key at all. Are you able to understand, ma'am? So here, if you are using key, that indicates that you are showing your authentication that this is my key. If you are using a key, that indicates that you are an authorized person. So with the help of a MAC, you can provide two services. What are those two services? One is authentication, and the other one is integrity. But with the help of a hash function, as for a hash function, we are not using any key. So it will be what? It only provides integrity. Authentication will not be provided by because we are not using any key for hash. The remaining will be same as it is. Let me show. So this is your variable size length. It is passing to hash. Only message we are passing. No, I'm not using any key. So that you are generating what? Fixed size length called a hash. Okay. Now see here, almost what we have in a MAC will be having in a hash. But let me show the difference. I already given a clear idea about the differences. Now let me show this. See here, we have a message. Okay, this message we are sending to hash. Okay, so previously for MAC, for C, what we have given, one is a message we passed, and the other one is a symmetric key K1. Okay, K1 or K2. Okay, but in this case I already said that for this hash function, there is only message. We are passing only message, so that the output from this function will be what? A fixed size variable, fixed size fixed size length of a message you will be getting. Okay, so in this case, this is your message. We are starting with simple authentication. We'll be going afterwards for providing confidentiality. Okay, so now this is your message we are sending to H. Why? Because we are now in a hash function, not in a MAC. If it is a MAC, we will send that to C. As we are in a hash, we are sending this message to H, and what will be generated? Fixed fixed size message will be generated, which is also called as MD, message digest. We will be calling this as message digest. You should know this, ma. Why? Because how this fixed size is generated, we will use a next topic is the algorithm, how this variable size message is converted to fixed size message. For that we will be studying about the next concept called SHA. Okay, so for that you must know how this is converted to fixed size message. Okay, so try to understand the basic concepts. So for the next concept, so here the message will be given to hash function. So message fixed size message will be generated, hash will be generated, and that hash and your plain text both will be concatenated. And next is what we are providing encryption. If we are providing encryption means we have along with authentication, along with this not I should not say as authentication, along with integrity we are even providing confidentiality. So here it is encrypting with a K, which is symmetry, so that you will be having what? Message concatenated with hash message. which will be encrypted with K. So here what receiver has to do, receiver has to decrypt with K. So it has decrypted with K, so that what receiver will get, ma? Can anyone? One part is appended with message and the other part is appended with what? Hash message. I can even say that as message digest. Okay. So this will be received by the receiver. The sender will send a plain, what is this? A plain text. I cannot say this as a plain text. Initially it will be in it will be in an encryption. So what receiver will do? Receiver will decrypt with the K. Okay. The key which is used by the sender, the same key will be used by the receiver. After decrypting, the receiver will get a plain text and the hash value. And what receiver will do? Receiver will calculate the same process that the sender has done. The sender will send this message to hash function, so that the receiver will get a hash value. This hash value and the value which is sent by the receiver, both will be compared. If same, what receiver will do? If it is same, what receiver will do? Will it ignore? If it is same,
He will accept.
it will accept. That means while transferring from one place to another, so there is no tampering done by any attacker. So that is hash. Okay. Now think, there are so many techniques that we are using in a hashma based on the type of application we are using. So based on the requirement, we'll be selecting any one. So there will be totally, see here, so until F methods, there are different methods that are involved in hash. So which one to be selected will be based on what type of application that you are using, what type of uh, what you need, what service you need. Based on that you will select any one. Okay. So first one is completed. Let me go for second one. So this is your second one. This is your message. Same, until here is same. This is your message. Okay. So that message, what Alice has done, Alice has sent to a hash function, so that hash code will be generated. Which is, hash code is what? Hash code is what? It generates fixed size length, which is also called as a message digest. We already discussed in a crypt tool, when a variable size key, if you are applying, when it generates what? Fixed size length. So hash code is a fixed size length, also called as a message digest. This message digest, it is encrypting. See here, it is encrypting with K. It is encrypting with K. Next is what? It is encrypting with K. Okay. Next, it is concatenating with M. Okay. With M. And here what receiver will receive? Receiver will receive, one side is a message and the other side is the hash function, which is encrypted with key K. Okay. Next is what? Next, the receiver will receive this hash. Okay. Receiver will receive this message and the one which is encrypted. So the plain text will be sent to hash function, so that receiver will receive a hash function. But this hash function is not in a normal text. This is in an encrypted format, which is encrypted by K. This has to be decrypted by the receiver, so that receiver will get a h of M. So both will be compared. Okay. Now I will ask you, will it provides confidentiality or will it provides authentication? Think about it and tell me. Will this provide confidentiality or authentication? If you answer this, I know that 100% you understood the concept. Just to give the diagram name, I will accept. Upon receiving, what type of services it is providing this diagram? Anyone, please? Think about confidentiality. If you are sending ciphertext instead of plain text, then you are providing confidentiality. Are you sending a plain text or ciphertext? Think about it. Are you sending plain text or ciphertext in this diagram? Huh?
Plain text, ma'am.
Means is this diagram providing confidentiality? Is this providing confidentiality? No. It is providing what? Authentication. Why means it is using K by Alice and it is using the same key K by Bob. Means both are authorized person. If both are authorized persons only, they know the key, or else the unauthorized users will not know the key. So it is providing confidentiality, but in this case, it is not providing authentication. It is providing, but confidentiality not providing. Why? Because the plain text, "Hi, hello, how are you?" We are encrypting "Hi, hello, how are you?" and we are appending "Hi, hello, how are you?" with the key, with we are encrypting this with K, the HM. Okay, HM means one will be the message digest, which is encrypted by key K, but this is plain text. Means what? Why we are encrypting this actually? For showing the proof that I am an authorized person. Why we are encrypting this is only for proof that, only why we are going for encryption is only for showing that you are an authorized person. So what receiver will do? Receiver will also receive this and will decrypt that with the same key. After that, the receiver will get a hash function. This function and this function both will be compared. If both are same, then it provides authentication, not confidentiality. Coming for the next diagram, see. Uh, can anyone? I won't explain. Ma, this is the third one. You must analyze. Tell me. See here. Think about the message. It's starting from message, where it is converting to plain text. Write down a side that it is converting to plain text. So let me start with the first one. This is your plain text. This is your plain text. So in this you got a message digest h of m, and this h of m asking about Mac. So for C, what
Okay.
will pass?
Message and key, ma'am.
Okay, for Mac we'll be passing message and key. What about for hash?
Only message.
Only message. The difference between both is what? Mac will use a key, but hash will not use a key, right? So if hash is not using a key, we can take help of symmetric and asymmetric for providing a key. Means for providing authentication and confidentiality. Okay. So whereas in a Mac we'll only use symmetric. See here. Whereas in a Mac Whereas in a Mac, we only use symmetric. This is your Mac. We only use symmetric. Never you used in a Mac public and private. Hash function, whereas in a hash function, for providing authentication, we'll be using symmetric key. Okay, that is one way for providing encryption, and for providing confidentiality and authentication, we'll be using symmetric. And the other ways, you can even go for asymmetric also. You can even go for asymmetric also. You can even go for asymmetric also. So, symmetric and asymmetric keys you can use for providing services called authentication and confidentiality for hash functions. For hash functions, okay? So this is, you are using a symmetric key for providing. This is also you are using a symmetric key. And this is, can anyone tell me what is KRA? What is KRA and KUA? Yes, ma, anyone? This is your, in this diagram we are using asymmetric schema. Asymmetric key means we'll be using two keys. One is private key and the other one is public key. Okay. So, so for providing authentication, for providing digital signature, what we will do is the message will be sent to hash function first. Then from this hash function, we are encrypting with the private key of A. This is your A. This is your B. Okay. We are encrypting with private key of A so that this will be appended with the message, and you are sending the message directly a plain text. You are not doing any encryption, and this side you will be having one side as plain text, the other side is a hash. which is encrypted with the private key of A. So if it is encrypted with private key of A, it has to be decrypted with which key? If it is encrypted with private key of A means it has to be decrypted with which key? You are seeing no? What is this key? What is this? It is decrypting with the receiver is decrypting with what? Which key? చెప్పండమ్మా ఏంటది KU indicates what? What is this? Huh? What is this, ma?
Public key, ma'am.
Okay. So this is the public key of A. So if receiver is encrypting with the private key of A, it has to be decrypted with public key of A. So that what receiver will get? Receiver will get a hash function. So this hash function and the message converted sender to hash function both will be compared. If both are same, then this will be accepted. Okay, the same these also the message is given to hash. This hash it is encrypted with in this case it only provides digital signature, ma'am. It only provides digital signature, whereas in this case along with the digital signature it also provides confidentiality. Why? Because it is encrypting with the private key of A. Here you can decrypt with the public key of A means it provides that this is an authorized person. Along with that, if you want to provide confidentiality, we are encrypting here. We are converting this plain text to ciphertext so that with this key, the receiver can decrypt that. Okay, means it provides digital signature and confidentiality. In this case, there is a message. This message we are taking on a secret key which is shared by the sender and the receiver. This secret key appended so that we will be getting a hash. This hash and the message we are appending so that here receiver will use the same secret key which is used at the receiver side, so that what receiver will do? Receiver will append to that message and the secret key so that receiver will get a hash. Both will be compared. So if same, then it will be accepted. Here also the same process, but in this case it only provides authentication. So in this case it provides authentication and encryption. Okay. So this completes your MAC and hash function. For the next class we will be discussing about hash algorithm.